yesterday you did this. You have two sides, perfect square trinomials, and the other side was different squares. We're going to get into this a lot more in the future, but today was just yesterday was just the intro. So the takeaway I want you to have is this. Remember that this is just like a times table. Each row and column multiplies to fill up the empty square. So x times x equals x squared. And then this empty square would be x times 4. And this empty square would be the same thing, 4 times x. And this last one would be 4 times 4. And then we saw that on the diagonal you get like terms. So 4x plus 4x would be 8x. So our final answer will always start with this and end with this. So we'll start with x squared, end with plus 16, but in the middle we're going to combine these, and that's going to be 8x. Now here is the takeaway, which really is the most common mistake that we see in this chapter. What if I didn't want to do any of the box? I wanted to save myself 5 seconds of work, and I just wanted to do this. You get the same answer. And that's what so many people end up doing. They want to skip the 5 seconds of writing the work down and say, oh, you know what, I'm going to make it my own way. Even though I haven't passed this class, I'm going to make this up, and I'm going to do it this way. And that's bad. Okay? So don't do that. That's the takeaway. Is that it takes 5 seconds and you'll get the right answer. I mean, it's close, but you know in a multiple choice test, we have A, B would be this, and you might have, okay, 2 out of 3 correct, but, so that's about, what, 67% correct. But what happens if you choose this answer on a multiple choice test? What if you chose this answer? How many points do you get? 0. So you might be thinking this. This is reality, though, right here. You get nothing. So 5 seconds of work, you get 100%. When you start making up, I don't want to write out a box or whatever like that, that's when the problem starts. So keep that in mind, is that you can do, part of it right, but you really get nothing for it. So why would you do just a little bit when you know you're going to get nothing back? Okay, it's like working half a day and not expecting to get paid. You actually get 0 at the end of the day. Doesn't make sense. Stay a little bit longer, get everything. So on all of these, I want to be very careful and conscious about it to not just, I'll make this up. Okay. Always going to be this middle term. Well, almost always. 14. Plus 14. Get that middle term. So that was the front, which I really wanted you guys to see and understand. That being said, so what if I did another one, so 2x plus 3 quantities, how you say that squared, what would this equal? First of all, what does it not equal? Based on what we just said. Yeah, this is not 4x squared plus 9. That's wrong. And so when you see it written like this, you have to understand that it means this. Even though there's, they don't give you 2 sets of parentheses, that's what the exponent means, 2 of these things. And then you can make your box and get your answer. Okay? All on the back side, the flip side. It's there. Okay. Similar. However, on all of these, what happened? All the middle terms ended up equaling 0. So it's not that you can't have 2 terms, right, as an answer. Back up on the front side, we said, make sure it's not x squared plus 16, it's not x squared plus 49. It's not that it's because it's 2 terms it's wrong, it's just it's missing something in the middle, right? So you don't want to say, okay, anytime the 2 terms is wrong. Not necessary. It's okay if the middle actually equals 0. So we could write it like this, but we just choose not to put in the fact that this equals 0. Choose not to put it. And that's what happens here. So if you look at the numbers closely, you can see when does this pattern happen when you get a 0 in front? When does this happen? When you have opposites. One positive, one negative. And then you get not too bad. Now, what we're doing today, we're going to do this whole process backwards. I'm going to give you what goes in the boxes, and then you're going to come up with this. In other words, you're going to undistribute, also known as factor. You're going to factor. I'm going to give you some that you have to distribute, like here. It says to find a product when you do the sugar property. So just like normal. And multiply. 5 times 3a. 5 times negative 6. So the answer is simply 15a. What if I gave you what's the answer here, right? And I told you to factor, undistribute, go backwards, undo this. So that means I'll put it in here, and then I have to come up with what goes out here and out here. So if this is multiplication, like 5 times 3a is 15a, what can I divide out of both of these numbers? 3. But in the same way, like a times table, they must line up. Okay? So 3 up here? 5x, yeah. So they still have to multiply. 3 times 5x equals 15. Same way I did over here. They have to equal. 3 times what is negative 4? Negative 4. And then we can write our answer. It's going to be 3 on the outside, and then the 5x minus 4 on the outside. Just like that. So I'm going to give you some pairs of problems. One of them is to multiply in, distribute. The other is to factor, undistribute, go backwards. So let me pass this out. I can copy that down, and we'll do a few more. Alright, so once again, when you're factoring, that means you're doing the box backwards. So we have this. Right. Now, what can go into 10 and 50? Negative 5 and 2, right? What else? 10. So the question is, which one do you use? 2. There is only one that's going to be correct for a very good reason, which I'm going to tell you right now, and you're going to find out why next week.
5.
Find out next week, but you have to have faith with me right now about which one to use. Okay, so which one?
5.
And is there a mathematical reason for 5, or it's just I like? Why not 10? So from now on, these are known as common factors. I'll abbreviate CF. 2 is a common factor, it's in both. 5 is a common factor, it's in both. 10 is a common factor, it's in both. But you know what? 10 is also the greatest common factor. And for everything we do with factoring, we're going to use not just a common factor, but the greatest common factor. And that's a must. Okay, that's a must. So we have to use 10. Have to use 10. That's why I want you guys to stop at 4. So it shows you that you may not intuitively always pick the right number from the very beginning. So it's something when you're deciding what number to use, you might have to make this list right here. Might have to make that list. Also, variables. What do they have in common, variables? There's 4 right here, there's 1 over here. So what do they have in common? They have just a, 1 in common. 8 and 1 in common. If this was a 2, they would have a squared in common, because this would have 2 and this would have 2. They at least have 2. So for the biggie here, and if there's going to be a mistake, it's going to be about this number. Okay? It's going to be about that number. And again, why does it have to be the GCF? When we're solving equations next week, you'll notice when we finish this, so you'll have what? A to the third, right? 10a times a to the third is 10a to the fourth. 10 times what is negative 50? Negative 5. And we don't need another a. What's left over, we're going to end up solving an awful lot. Okay? And when this is smaller, it's easier to solve. So if you took out a 5, right, you notice this is like 2a to the third minus 10. The numbers are bigger. We want to get these numbers as small as possible, so when we start solving and graphing, it's a lot easier with smaller numbers. If we had to graph this, that's not going to be too hard to graph. But if you only take out like a 2, and you had to graph, if they took out a 2, that would be 5a to the third, and that would be 25. This is much harder to graph. Just because the numbers are bigger, it's going to be much more difficult. Imagine how much more you're going to have to count up here because you're at negative 25, right? Your y-intercept is going to be negative 25 way down here, but if you did the GCF, your y-intercept is only negative 5. Much easier to graph and solve when you actually use bigger numbers for your common factors. So that's the reason it'll make your life a lot easier down the road. All right, so write your answer up here, 10a, and just like that. So you go ahead and do 5 and 6. Notice how I left the box off. I know some of you maybe don't need it, so it's up to you. Remember, you're going for accuracy, not speed. So I don't want you saying, oh, okay, I don't have to use the box. I don't have to do extra writing for 5 seconds. I'm not doing it. And then you get it wrong. You need it to use it to get it right. 5 seconds, 100%. Work. Always work. So use the box for both. And then, of course, check with someone next to you. So if I call on you, you're not going to have this nervousness like, oh, I hope I got it right. You've already checked with somebody around you. You know it's right. You never have to be nervous about me calling on you because you've already checked your work with people around you. You never have to say a wrong answer in front of the whole class. You've checked it already with people around you. Go ahead and do that. Take about 3 minutes. You want to move on to number 7? Multiply that out. I've already put in the box for you a little bit. And if you're stuck, talk to someone next to you. All right? Don't just say, oh, okay, I'll wait. Just write it down. You will not learn how to do it if you just wait for talking. You must talk. You must want to learn how to do it. Alright, let's look at here. Remember, factoring is on the inside. On the inside. Okay. Hey. So, let's look at number 6. Timothy, what number did you choose for the GCF? Okay, would you? Timothy, Zach, what did you guys come to? Okay, so when that happens, make sure you talk to somebody in front of you and behind you as well. Don't just say, I tried one person. And oh well. You got to do more than that. All right. So anybody else? What number? Yeah. 2. Yeah. 2 is the biggest number that goes into 6 to 16. What about the variable? Do we have a variable? Do these have anything in common? Just an R. Just 1. This has 1 R, this has 6, so in common they just have 1. They both have 1. And then we can work backwards to finish it. So it's 2 small steps. The biggest number that goes into the number, and then what variables are in common. Alright, so 2 times 6 is 3. And then R to the 5er. 2 times what is 16? Do we need a variable?
No.
We already have an R. Any an R. Alright. So write it up here. And remember, I will. Oh, oops, I'm writing that wrong. Again. R, and then 3 R to the 5th. There you go. What happens if you put this back in the box and you did the Schroeder property? What would happen? Yeah, you get here. So you can check your answer. You don't have to hold. You can check with somebody next to you now, but when you're by yourself, you can check also. Doesn't require any more writing, just visually. Okay, I can see it. Alright. Let's go down to 7 if you have more. Multiply that out. It says find the product, so that means multiply. I'm always going to put the first binomial vertically. The second one's always going to be on top. Not that it has to be that way. If you switch them, you'll get the same answer. I'm going to do it that way. Good. Multiply them out. See what you get. Go ahead and try it on your own. Check with mine up here. Do not wait for me to do it and then copy it. So try it on your own. Okay. Check it. Self-check. Go. Now, what term goes in the middle? 10, close. 10x. So 42 minus 32 was it 15? Let's do all that backwards. So let's factor. You got 4 terms. So instead of putting these on the outside, we're multiplying. Those 4 terms are what go on the inside. So we're going to do 5 m to the 3rd. This is already written on yours. Okay. And then we're going to find the GCF. All right, we got to do the GCF, just like we did here. And just like we did here, where it had to be 10, not 5 and 2, it has to be the greatest common factor. There we go. So what number do we have in common? 5 and 2?
1.
1. All right, 1. What about the variables? What variables have in common? Hammer. What about the first column? What number do these have in common?
5.
And what variables do they have in common? Now check it. Does it work?
Yeah.
Okay, so you can do this 2 ways. GCFs or making sure it multiplies properly. Now, look at the bottom. You can do this 2 ways. Okay. You can do this 2 ways. You can either do the GCF of the bottom row, or you can say 5 times what is 40? 8. You get 8. So maybe you look at this and say 40 and 16, I can't think of it. But maybe you know, okay, I know 5 times 8 is 40. That's easier. You know you can do it both ways. It works the same. What about variables? Do I need variables? No. Okay, finish it up. So you can do GCF of this column, or you can say, well, 8 times what is 16?
2.
Yeah. Either way, it's the same thing. What's the GCF of these two?
2.
2. So you get the answer no matter what. Go ahead and write it up here. I'm going to write just m plus 8 and 5m squared plus 2. That's the process. Too bad, not too bad. I want to start one more on the back side here. Let's look at number 10. Why don't you go ahead and fill in the numbers into the right square. Fill the numbers into the right squares on number 10. So we got what, 24? And that's how we start with middle. And what terms over the go down. Second column. Did I do it right?
Yeah.
No.
Negative.
Okay. So negatives do need to be in. Signs do need to be in. Don't leave them off. Don't change. Yeah. Again, we don't want to do 99% correct. Miss one little thing and get 0 points because we forgot one little. Alright. So, you have a choice. You can start anywhere, really. You can do the first row, like what's the GCF of 24 and 64? Or you could do the GCF of 24 and 9 in the first column. These numbers are smaller, so it might mean it's easier. So what's the biggest number
8.
that goes into 24 and, you want to do the row? Okay. So the biggest number that goes into 24 and 64 is? What about variables? What do they have in common?
8.
And up here, you can do the GCF of these two, or you can say 8 times 1 is 24. Same answer. What variables do they have in common? P squared. Gotta have the squared. So we have 1, 2, 3 all together. You finish it up probably. 3 times what is 9? 3. Do we need more variables?
No.
Got 2. Need 2. Good. What about over here?
Negative.
Yeah, you'll notice these have what in common? A negative. So that comes out as well with the number. So the negative in the same row and column, you bring that out. Bring up. Okay. And lastly, we're almost done. What have we not done yet? Yeah, we haven't actually written the answer down. So this is just a tool to get us the right answer, but we want to write the answer out. Equals 8p plus 3 times 3p squared minus 8. And then you're finished. Alright. Once you finish that, feel free to work with somebody. Work with somebody means try it on your own and check. Never do you want to just look at theirs and say, okay, I got it written down. Tomorrow when I give you a quiz on it, you fail because you don't know how to do it on your own. It's okay to check on your own, and of course you can ask me. Alright.